Okay, on Tuesday, we were looking at rearranging equations essentially. Okay, so looking at rearranging equations, looking at transposing. Okay, so now we look just a wee reminder of where we were. Okay. Given a question like that, and in the brackets you'll be given something that they want to put as the subject of the equation. Okay, it was on you to go through the various steps. Okay, looking for what you have to move over. Okay, in the process that we followed, we were wanting to get over to the left-hand side immediately. The letter that was going to be the subject of the formula. So in this case, the T. So we just swung round the whole equation. Okay, swung round the whole equation. So it was on the other side. Now we need to get rid of each of the letters that surround the letter T. Okay, now that 2T is in the bracket. So we need to get rid of everything out with that bracket first. All right, now there's a barrier. Remember the barriers that we spoke about? There's a barrier which is a fraction here. The fraction's that divided by n. So we can move that across. And it becomes a multiple on the other side. Okay. Now, they'll do this quite often where they'll have something like a p squared or something. You're moving that whole thing. Okay, so that's p squared times whatever's in that bracket. So to release what's inside that bracket, you need to move everything out with it. Now that p squared goes across the right-hand side as a whole. Okay, everything goes across the right-hand side. So it's 2t plus 1. All right, because we're moving that p squared, the bracket can disappear. It's NB, and the p squared goes in the bottom. Okay. Now we can move the addition. We'll get that. And then moving that t over, that everything there, you can put in a bracket and divide by 2. Okay, so everything there would get divided by 2. I've run out of space, so I'll do it up here. All of that would go over 2. Okay, so that's quite difficult to see. Okay, you can even put that in brackets if you want. So we're giving ourselves sort of big challenges when we're moving stuff across. Okay. Left with one last thing that I wanted to go through. It changes the process slightly. Okay, and it's the most difficult way they could sort of ask this. And it's changing the subject. Okay. When the variable is the bottom of a fraction. Okay. So we're changing the subject when the variable is the bottom of a fraction. Now for this, you don't need to change the sides. You don't need to do that first step of the process. Okay. Okay, so up until now, we've been flipping the right-hand side and the left-hand side to get the variable that we wanted over to the left-hand side. Okay, but because it starts on the bottom, okay, a question like this. Okay, we're changing the subject to x. Okay, because we've got a case like that, we keep it as is. Okay, and the first thing we do is we can move that x over, and it brings it to the top line. Okay, so if we brought that x over, it becomes a multiple on the left-hand side, but importantly, it goes to the top line. And then we can isolate the x. Okay. We don't write this, but if we flip that side, okay, and we try to change that 4y, we try to move that 4y and leave the x isolated, we'd have to leave 1 over x. Okay, because we'd have to leave something above that. That x is in the bottom of a fraction. Okay, now that's not how we want to leave the equation in the exam. Now that's mathematically correct, but that's not how we want to leave the equation in the exam. We always want to leave the variable that we're looking for, in this case x, on its own, on the top of a fraction. Okay. Saying that, some rules still exist. Okay, so if we had z equals 6 over m plus t, and we were changing the variable to m, okay, what we'd have to do first is get rid of that addition and subtraction. We can't move the m straight away, okay, because it would affect that addition. So that's z minus t equals 6 over m. Now at this point we can move that m across, but that m now multiplies everything on that left-hand side, and it becomes m z minus t. Okay, so that means that m is multiplying with everything on that left-hand side. But writing it in that way, with a bracket, okay, means I can move that whole bracket in one move. Okay, I can take that all over. Okay, so that bracket that's being multiplied by m, so I can take that bracket all over and it becomes a divide. Oops.
Daniel, can I ask a wee question just now, please?
First can.
Thank you. Would we get marks taken off us if the equation is written the opposite way around, even if it's in the right form? Like if we did x equals 4y over m, would it make a difference if we wrote it as 4y over m equals x in the exam? Does it matter?
So it'd be harder to do it, but so write it like that.
Yeah.
Yeah, that's still mathematically correct.
Right. Okay.
X is still the subject of it.
Okay. Thank you.
You're thinking of spinning the equation round anyway? Just
Yeah. So
keeps it
the one. Yeah, so see the one we were dealing with when we're trying to work out with the variables in the bottom of the fraction. I worked it out a slightly different way because I found another example that I kind of took a stab at, and admittedly I got it wrong first time, but anyway. But what I did was I moved the fraction over to the other side instead of doing it the way that you've done it. Your way is actually a little simpler to do, a little easier to work out. But I was just curious in case, on the day I kind of did it the wrong way around and it still came out, because it came out as being the fraction part of it equals x rather than the other way around, but every other example that we've done has always been the other way around. So it was just in case it kind of worked out that way, but I think I'll do it your way.
If that's the case, you can just spin it round.
Mm.
And just have your last line. Because remember that equal sign is just like the middle of a seesaw. So
Right.
as long as the left-hand side and the right-hand side are equal to each other, if you just spin that round, then that x equals 4ym is the same as 4y over m equals x. It's the same whatever way you write it.
Right. No problem. Thank you.
It's like 3 equals 2 plus 1 is the exact same as 2 plus 1 equals 3.
Right.
So it doesn't, you can switch it around and it means the same thing. So
Okay.
I would say no.
Okay. Thank you.
All right. Just getting used to when we have indices. So when we've got a squared number or a rooted number, okay. Remember you move that as a whole. So we're not moving just the squared part. We're moving that whole x squared across. Okay. Then we can tidy that up. Remember that root has to go all the way over every part of that. Okay. Very important. Last one, let's do 3 over root x plus 4. Okay. That whole x plus 4 with the root, okay, that can all come over. So that's one term, I suppose. All right, because that root encapsulates all that x plus 4, I can move everything underneath that 3. I can move that right across, so it becomes, don't have to necessarily put that in a bracket either. Okay, but if it makes sense in your head and it keeps it a wee bit tidier, let's put it in a bracket. All right. Okay. Now, oh, forgot to put. Now we're trying to isolate that x. Now that root sign is covering everything there. So we need to remove that root sign before we can move the plus 4. X plus 4. Right. Make sure that whole thing's squared. And then that 4 goes across and you're removing 4 from all of that. Okay, so moving and transposing equations, sometimes a little tricky, all right? Sometimes catches you out. It's just all about practice. And that's, once you get used to moving roots across and when you move squares across, okay, when you can move a multiple and divide, it gets a wee bit simpler, all right? But again, it's just practice. If there's any that come up and you just cannot see where it comes from, then let me know and we can do it in class, okay? Okay, so that was just finishing off Tuesday night. What I want to look at tonight is moving into a section called chords. It's to do with circles, okay? I'm going to start it by looking at triangles. Okay, so just a wee recap on Pythagoras. You know, okay, we'll do a little bit of trig as well with SOHCAHTOA. Now, a lot of this stuff stems from sort of Nat 4, so it's assumed knowledge. Okay, but some of you haven't done it in a while, so I'll just recover it, hopefully quite quickly. All right. In Nat 5, we use find missing sides or prove, okay, something the right angle. Okay, so the light proof questions. Okay, so we use Pythagoras theorem to either find a missing side and use that as a bigger part of the question. Okay, or it's to prove something as a right angle. Okay, and that's called converse of Pythagoras. Okay, so Pythagoras is to take into account right angle triangles. Now, do I have a triangle? What have I got? All right, so it takes Pythagoras theorem is used for triangle with a right angle. Now, the right angle is sometimes illustrated with a wee square and the angle that's right, okay? So a right angle is an angle of 90 degrees. Okay, so a right angle is an angle of 90 degrees. So you've got different types of angles. You've got acute, which is 0, well, 1 degree, I suppose, 1 to 89. Okay, anything under a right angle. So a right angle is your 90 degrees. You've got obtuse, which is greater than 90, so 91 to 180. And you've got reflex, which is 180, 360. And then the 360 is the full circle. Okay, so you've got different angles that you need to be aware of in that 5. Okay, the right angle is the focus of Pythagoras theorem. All right, in a right angle, we've got the 90 degrees. In a right angle triangle, the longest side is the side opposite that 90 degrees. Always. Okay, it's also known as the hypotenuse. Okay. And then the other two sides are always shorter. The order of which doesn't matter. Now, this is taught quite a few, well, a couple of different ways. You might recognize it as a squared equals b squared plus c squared, or for whatever reason, they changed it to c squared equals b squared plus a squared. So, what I would say is, whatever you're comfortable with, use. Whatever you remember learning, use. What I'm going to refer it to, which always is going to be the case, long side squared equals short squared plus short squared. Okay. Because it doesn't matter. For Pythagoras, it doesn't matter. As long as you identify what the long one is, the long side squared equals the two short sides squared added together. All right, no matter the order of them. Okay, so we look at that, example 1. call that side x, side 14, side 7. If you're trying to find x, find the missing side. All right, they might just use any letter, or they might use 2 points, okay? But if you're trying to find the missing side, you can label however you want, okay? Remember, it's just the long side squared equals the short side squared plus the short side squared. Okay, so the long side squared we've just labelled as x, short side 14 squared plus 7 squared. Okay, x squared equals 245, and now just a case of working that one out. Two decimal places unless it says otherwise.
Wait, how come you've not got 245 plus 49?
14 squared plus 7 squared is 245. Huh?
Or is that it in total?
Aye.
Sorry.
Aye, 14 squared is 196. All right, so that's how we sort of use that. Okay. Now, may become, or may be a bit tricky if it's a funny sort of direction, so it's upside down. It might not be overly clear what one's the biggest, all right? But the longest side always cross, all right? If it's a question like this and it's simply just looking at Pythagoras, they might throw in a wee thing like changing the type of units. So they might go centimetres and they might go 110 millimetres. All right. That's a possibility. They've done it before in the exam where they've put more than one type of unit. All right. So being aware that they have to be consistent. All right. You need to use the same units throughout. You'd have to convert. Okay. So kilometers to meters. Okay. Dividing by 1,000. Meters to centimeters. Dividing by 100. Centimeter to millimeter. And dividing by 10. Okay, and then going the other way. All right, so there's 1,000 meters in a kilometer, there's 100 centimeters in a meter, there's a 10 millimeters in a centimeter. All right, so they might throw something in there just to confuse you a little bit. So 110 millimeters, okay, is going to be 11 centimeters. Okay, and then it's just Pythagoras. Long side squared equals short side squared plus short side squared. X Remember the units at the end. Okay. So Pythagoras is used, and we'll look at one of the past paper questions. It was used for bearing. bearings, okay, so that might throw in kilometers or it might throw in meters, so just knowing that you have to be consistent there. Okay, just using the same units. Very, very rare, but it has come up once. All right, what should be a simple question might just throw you a wee bit. Cheeky. What else they like to do is throw in a wee surd. Okay, so I had you look at surds on Tuesday. Okay, but might throw something in like this. And there might be a non-calculator. Okay, so in the non-calculator paper. Question would be express x as a surd in its simplest form. All right. Again, what looks quite a standard, simple question. Okay. Throws in a wee curveball just because it says sub. All right. Oops, what was on there? Okay. So again, long side squared equals short side squared plus short side squared. That's how you'd work it out. It's a right angle. Okay. And long side squared was labelled as x. Short side squared, we've got 8 squared plus 4 squared. Okay, so 8 squared equals 64 plus 16. X squared equals, what's that, 70, 80. Okay, so we get to that point in a non-calculator paper, things are going quite well. And then we need to move that over. Now remember what goes under a root. Okay, we're looking for two numbers that multiply together to give you that number. Okay, but for 80 that doesn't exist. 80 we can't root perfectly. Remember when we were doing these questions, what we're looking to do here is just simplify that as far as possible. So we write out all our squared numbers, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way up past that number. So we're looking for something that multiplies in so we can simplify that down. So 64 doesn't, 49 doesn't, 36 doesn't, 25 doesn't, 16 does. All right, so if you look at 16 times 1, 16 times 2, 32. Oops, times 3, 48. 4, 48, 54, 64. Times 5 is 8. Okay. So we've got 7 times 5, we've got 16 times 5, which means we can simplify that down. Now, that's not an obvious one. All right, again, more surd questions you do, the more times we simplify these surds down, all right, the easier these will get to identify. So x in its simplest surd form okay, root 16 is 4, 4 times 4, 16, and we're left with 4 root 5. That's the answer there. So it's giving you a wee bit of Pythagoras, but it's asked you to put it into the simplest surd form. All right, it's just a different way they can sort of ask this question. Now, we'll see later in the chords questions when you use Pythagoras. as Pythagoras, and sometimes they'll throw in a wee thing like that. Okay, but more often than not, in that 5, you'll use it to find the shorter side. Okay, so those examples we were doing there was used to find the longest side. Okay, the long side squared equals short side squared plus short side squared. Okay. Yeah, so we're rearranging, find one of the short sides. Okay. Remember, long squared equals short squared plus short squared. Okay, so if I'm looking for short side, I can rearrange that equation, and it will be long side squared minus short side squared. Okay, now I still don't need to label them up per se by like different letters with my A's and B's and C's, okay, which you get taught in school. That works, okay. If you've got a short side and a long side, as long as you're taking away the short side from the long side, you will find out the missing side in a right angled triangle. All right. So you don't need to label A's and B's and C's, okay, and confuse yourself. And if you want, comfortable with it. Okay. Find X. Short side squared equals long side squared minus short side squared. All right. If you want to start every Pythagoras question, the long side squared, short squared, or short side, and then rearrange it, okay, that's absolutely fine. Long side squared is always the longest side, obviously. 18 squared. To the next. Okay, simple as that, and then whatever units to use. Okay, so I'm going to give you 2 to try. All right. Now, these are both non-calc. Okay, it throws in a wee bit of sub question. Okay, so X. Okay, this was non-calc. Okay. Again, non-calc. Yep. Best. All right, have we look at that? Give it a wee bash for 5 minutes. All right. Then come back. All right. Okay, second one looks a wee bit worse. All right, but once you think about it, so if you do short side squared equals long side squared minus short side squared, and the x this time is given, okay, you've got root 50 squared, and you've got root 32 squared. Now a root times itself, so remember squaring a number is the number times itself. So root 50, don't need to write this out, times root 50 will give you 50. All right, so squaring a root number will just leave you with that number. It's 50 minus 32. 18, I think. 18. X is root 18. Okay, simplifying that down. All right, hopefully it won't take you long. 1, 4, 9, 16. It's not 16, it's 9. 9 times 2. Root 9 2. Okay. So it's actually not that bad. It looks quite horrible. In fact, it's root 50 and root 32. But when you remember, just squaring that means it takes away that root sign altogether, and it leaves you with quite an easy simplification. All right. Any questions on that? Anyone way off?
Do we have to show all that working for that example, for the last example? Would we, in the example, we need to show all those lines of working to get the full marks, or?
No. What lines are you missing?
Well, I'm so when I looked at that question, I looked at root 50 is already a square term because it's
Yeah.
asking you for the root of a already squared number, and the same thing goes for the 32. So I just looked at it really simply and went, well, what's 50 minus 32? And
Yeah.
I actually jumped in at the line where it says x squared equals 18. So I jumped right in at that point.
I would say show at least one more line of working.
Right, okay.
It's fantastic you jump into there, all right? But you need to be really, really prescriptive sometimes
Okay.
about what your thought process has been. So that's fantastic. You can go there already, okay?
Okay.
But always write the first line of a formula, just so it's little marks that you can pick up.
Okay.
That
Thanks.
few things, so even if you get the wrong answer, that process will allow you to pick up marks.
Right. Thank you.
All right. Worth it in the long run. So I would have said put one more line in. All right, one more line above that to show where that 18 comes from
Okay.
to get full marks. But I like the fact that you're there. Just don't get too ahead of yourself. Show off.
I actually did really bad in maths because I kept doing that.
Yeah.
That was why I lost so many marks, because I wasn't writing it all out. I was told so many times to do it and I didn't. So I'm trying to not do that this time.
Follow the process. What is it? Trust the process. All right. So another way they can use Pythagoras. So called converse of Pythagoras. All right, and sometimes like again. And that is the proof. Okay. So All right, as much as you look at this and go, why would I ever need this? It's actually a really common thing that you use knowledge about something to try and prove that it's true or not. All right, so it's just, I suppose, putting you into that frame of mind. Okay, so we want to prove using Pythagoras that a triangle is right angled. Okay, so calculate longest side squared. Calculate separately short squared from short squared. Okay. Compare and make a statement. Okay, a yes or no statement. Okay. Example. That's fine. Is this triangle right angled? That's it. All right. Step one, long side squared. Step two, short side.
Sorry, I can't see that wee number at the back of the triangle. Thanks. All right. It's as simple as that. Okay, you don't need to label it 1, 2, 3. Long side, figure that out. Short side plus short side, figure that out. And if the numbers match, then it's a right angle. If the numbers don't match, then your statement is long side squared does not equal short side plus short side squared. Therefore, the triangle is not right angled. All right. If I move too quick, I'm a wee shout. That's kind of threw me off. That I'm a bit confused by that.
So I'll show you the other way to do it. Okay, so you're trying to prove. Okay, now Pythagoras only works, it's only a right angle. Okay, this angle in here is only 90 degrees. Only if the long side squared is equal short side squared plus short side squared. So you're trying to prove that. All right, now you're not given
the information that is 90 degrees, you need to say whether it is or not. All right, so you need to say, you need to figure out, well, you need to just calculate long side squared, squared, which is 5776. Now, if this was right angled, then my short side squared plus my short side squared would equal 576. I can't state that already, so I can't start by writing that. All right, because I'm looking for it, whether it's true or not. Okay, I'm looking to complete with that. So I need to do it separately. That's why I'm doing it separately. So it's a lot clearer. Okay. 42 squared. That's 32 squared. Oops. So the long side squared doesn't equal, all right?
So does that mean then it's not a right angle?
Yeah.
Okay.
Okay. So it's 50-50 in what they give you, to be honest. Okay. If it's not the same, if the numbers don't match, then that angle in there is not right angled. Give these a try.
How many marks is this worth?
Probably 3.
Okay.
That last one, non-calculator. All right, so prove or otherwise. Okay, so 3 of them. Have a crack.
Is this the exact way that we can write it, like in the exam? Like the way that you've like numbered it, 1
The
to
1, 2,
3?
3. You don't need to necessarily label it like that. Okay.
Yeah.
But if you write it out like that, then it works.
Okay.
Well.
Thank you.
All right. But I would definitely do it separately. All right. I wouldn't do it as one equation, because then you just get a wee bit confused if it doesn't equal what it's meant to.
Yeah, that's fine.
Nice one. So I won't go through them both, but that one is. That one isn't. All right. This one's a wee bit trickier. So long side squared is equal to 21. Short side squared plus short side squared is equal to root 5 squared, which is 5 plus 16, which is also equal to 21. Okay, so therefore it is. Okay, so long side squared is equal to short side squared plus short side squared, therefore it is a right angle triangle. Okay, anyone get any different from that? Nice one. Okay, I just want to put it in one more type of question you could ask, and it's not a big change. Okay, but sometimes they'll throw in randomly bearing sort of questions. Let's have a wee look. Instead of me trying to go through it. So this is a past paper question. In A, B, and C, okay, the three corners of the triangle refer to three different towns. Okay, and it tells you A is due east of B. Is C due north of B? Okay, and you're given 72 kilometres, 97 kilometres, and 65 kilometres. Okay, now this makes the assumption that you know your points of a compass. All right, you've got your 4 points of a compass. Don't know why I paused there. Okay, so that makes the assumption that you know in between each point of a compass is a right angle. Okay. So what it's asking you when it's saying is C due north of B? Well, if A is due east of B and C is due north, that would have to be a right angle. All right, so it's a wee bit of a story thrown in, a wee bit of Pythagoras thrown in with a proof. All right, just to throw you a wee bit, but it's the same. Okay. So the way they can ask it is a wee bit, throw you a wee bit. Okay, so they could throw something in like that. Okay, so what we're going to move on to is using something called a chord. Okay, now what we need to be really clear with is this is very different from sectors and arcs. Okay, so we've been through a couple of rules of circles. Let's have a wee look. Circle, like so. Maybe I get a straight line in this. Surely not. Okay, circle. We've got centre, a line from the centre to the outside edge. Oh, that's good. That's rubbing that out. Okay, it's called your radius. Okay, that's a straight line from the centre to the outside edge. Outside edge to outside edge. straight line going through the centre. Okay, it's called the diameter. Okay. What we're interested tonight in is straight line, edge to edge, in a circle. Okay, but doesn't go through the centre. Okay, so a chord is a straight line. Touches two sides, side to side. Okay, a chord is a straight line that touches each side, so it goes from side to side. Okay, of the circle, but does not go through the middle. Okay, straight line, side to side, but doesn't go through the middle. Straight line, side to side, but doesn't go near the middle. All of those are chords. Now, when we're looking at chords, an important thing to know, if we take a line, straight line, from the centre of our circle to where the chord meets the edge, the length of this is the radius. Okay, now that's important, we use that quite a lot. Okay, so what I mean is we draw a line, straight line from the centre, that could be better, centre to where the chord is meeting it, then that line's length is the radius of the circle. Okay, so from the centre, straight line to the outside edge where the chord meets it, that's the radius, straight line. Okay, so that's the first part. The second part, what we can do is we can create a right angle triangle. Okay, so with a right angle triangle, we can use Pythagoras. So create a right angle triangle by bringing a straight line from the centre to cut the chord in half. Now, it's that half, okay, half the chord length is what we will use going forward. Okay, so that's important. So what do I mean by that? Straight line from the centre through the chord, all right, and that cuts that chord in half. So that length there is the same as that length there. Create a right angle, that length is the same as that length, it cuts the chord in half. Creates a right angle, that length, and that length is the same. Okay, so creating that right angle is what you're looking to do in these questions. All right, seems quite easy, but then we can use Pythagoras off the back of that to solve. Put that into a question. Okay, yeah. What colour am I? Red. That's maybe the cross section of an oil tanker. Perfect in my eyes. Right, how do I use this? Can I use this? Get a wee bit better. There we go. All right, so in the exam, you might get given a wee picture like that. Okay, so we've got a circle, but what it's showing is a cross section of a tanker, all right, or a cross section of a pipe, or a cross section of something. Essentially, that's a tank with water in it or oil in it, all right? Of a tanker is shown. Surface of the oil is 250 centimeters. Diameter of the pipe, the diameter of the tank is 300. Find the depth of the oil in the tanker. Okay, what you need to be able to do is take that information and start piecing together everything that we need to do to solve this. Okay, so going back to my circle, if I redraw this, okay, without the sketch of oil, then about there. Okay, I can draw that circle like so. Okay, now if I say A and B, okay, A to B is 250 centimeters. Okay, so that distance from A to B A to B, okay, red dot to red dot is 250 centimeters. That's that part there. The diameter of the tanker is 300 centimeters. All right, so from side to side, going through the middle, centimeters. Now with that, with knowing what the diameter is, we don't need that straight line on the circle. Okay, we don't need to illustrate that per se to be able to answer the question. What we want with that information is an idea of what the radius is. Okay, because remember, we're going to draw a radius on, we're going to create a right angle triangle. Okay, so diameter is equal to 300, which means the radius is half of the diameter, so 300 over 2. The radius is 150 centimeters. Okay, that's something you just need to know. So radius is just half the diameter. Okay, so if we were to draw something that would be useful on a circle. If we draw a line from the centre to the outside edge, what we've drawn on is the radius. It's 150 centimetres. Okay. Now, what else can we do? Well, we can take a line from the centre and we can cut the chord in half. So we cut that chord that's 250 centimetres from A to B in half. Okay, we now know the distance from the centre to the outside edge. Okay, we know that that's 125. And we've created a right angle triangle. So what I'm going to do is find out the missing side of the right angle triangle. Okay, so these type of questions, it's sometimes quite hard to imagine what you're actually trying to figure out, but just create that right angle triangle, start working stuff out, start putting or using your understanding that you can do this, okay, and then see where it takes you. Okay, so I'm going to work out x. Okay, so I know that's a right angle triangle, so I know that Pythagoras works. So long side squared equals short side squared plus short side squared, but I'm missing a short side. So my equation moves about the long side minus my short side. Short side we've labelled on there as x. My long side's 150 minus 125 squared. X is equal to root of whatever that is. 6875. So x equal to 82.92 centimetres. Okay. That's not the end of this question. What I found out there is from that point there to the centre of the circle, that distance. Okay. That's 82.92. Okay, but I'm looking for the full depth of oil in that tanker, from the surface of the oil all the way to the bottom of the tanker. So I've got from the surface of the oil to the centre of that tanker. What I need now is from the centre to the outside edge. Now what that is, well, that's the radius. So that's 150 centimetres. So what I need to do now is say total height, or depth even, total depth of oil equal to 82.92 plus 150, which is equal to 232.92 centimetres.
Is that something that you'll likely see in an exam?
Yeah,
Yeah.
always comes up.
Okay.
See, once you've done a couple, they're not too bad. Okay, I'll show you, what's this, 2022. Okay. What's on your screen right now is a very, very similar question to what I've just done. Okay, so have a wee look at that. Try and think about it. So they've not shown the full circle, and that might catch you out, but that's a full circle, and that A to B is a chord. It's giving you the radius. Radius is the centre of the circle O to the outside edge, and it's 2.9 metres. Okay, so they've drawn that line on for you. If we bring a line down from O, so the origin, centre of the circle, and split that chord in two, then we're drawing a right angle triangle with a long side of 2.9 metres and the bottom of it of 2 metres. That allows us to find the distance from the chord to the centre of the circle, and then we can add on the radius to get the full height. Okay, so I'm going to draw that on the board. I'll leave that on the screen and I'm going to draw that on the board for myself, and then we'll go through it. Okay, but have a wee think about it, have a wee bath, add it if you want. Well, I'll just draw it out. Okay, I've drawn that out. Okay, so hopefully what you can see is if we bring a line down from the centre to the chord, it cuts that chord in half. Okay, and you're left with a right angle triangle, okay, with a long side of 2.9 metres and a short side of 2 metres and a missing side from chord to centre. What we want to do is find out that missing side. Okay, so right angle triangle. Forgot to actually write it out. 2.1 metres. Okay. So that missing side in there, 2.1 metres. That's not the final answer. Okay. Because we're missing from the centre to the top. And we know the radius, because it's given here. The radius from centre to the outside edge is 2.9 metres. The total height,
Sorry to interrupt, but I'm not getting 2.1.
okay, let's write that out a wee bit fuller then. So x squared equals 2.9 squared plus 2 squared, 12.41. Why did that give me
Oh,
See, I'm getting 8.41 take away 4.
yeah, I've added them together now. 2.9 squared is 8.41 minus 4, so 4.41 2.9. What did I say?
2.1.
What have I done there? I've got the wrong numbers.
Oh wait, no, I just got 2.1 there as well. I didn't get 2.9.
What am I doing here? 2.9 is alongside minus 2, 2.9. 2.9 squared minus 4. That's 2.1.
Yeah, that's fine. I got it now.
I don't know why. I must have put 2.1 in somewhere. Let's blame the late night for that. Okay, so it's just 2.9 plus 2.1. Hopefully you get that in the exam. And 5 meters.
Sorry, where did you get the, like, how did you know to do 2.9 add the 2.1?
Because the 2.9 is the radius. So any straight line from the center of the circle to the outside edge is
Yeah.
the same as the radius. All right, so the radius is given in the question. We go back to it.
2.9.
Yeah, so the 2.1 is our height from the bottom of the tunnel to the center of the circle. Is that blue line I've got there?
Oh, and then cause the diameter is half, like cause the radius is half the diameter, you would just use the 2.9 again.
Yeah.
Okay, that's fine.
Okay, so any straight line from the center to the outside edge is going to be 2.9. So if I go straight up on a vertical line from the center to the outside edge, it's 2.9. Okay, so that green line in the circle I've drawn is 2.9 meters. So when you may get asked to find the length of that chord, all right? So that's a typical question as well. There is 6. Right, you don't get given that. Right, sure. Okay, so
Distance A to B equals 8 centimeters. Okay, so that's from the outside edge to the top of your chord. Circle or distance O to C equals 6 centimeters. Okay, O is the center of the circle, so they'll often label the center of the circle O to state the origin, usually, okay? Use different letters, all right. One put point D over there. Time, length. Okay, so there's a lot going on in this question. Okay, so let's identify what they've given us. They've given us A to B being 8 centimeters. They've given us OC, which is centre of circle to the outside edge. And they've told us it's 6 centimeters. And they've asked us for length DC, which is the full length of that chord. All right, so they've asked us to find DC. Okay, so there's a few bits of missing information there that we need to find out. Okay, so that's the question. Let's draw a line under that and see what we need to start working out. Well, what can we find out? We can find out OB. We can find length OB. If we know that the radius is 6 centimeters, it means that we know that the distance from O to A, okay, the distance from O to A is 6 centimeters as well. So if A to, or O to A is 6 centimeters, and we want to know B to O, and we know A to B is 8 centimeters, then the missing distance is 2 centimeters. There's 2 centimeters left. Okay. 8 centimeters, which is given, minus 6 centimeters, which is the radius O to A, gives the side O to B 2 centimeters. Okay, I'm using a lot of letters, but the letters is just the start point and the end point. Okay. Now that line OB cuts the chord in half. Okay. Now that tells us that that angle in there is a right angle. So we've now got two sides of a right angle triangle. So to find length BC, we use the rules of Pythagoras. All right, so long side squared equals short side squared plus short side squared, but we're looking for a short side. So we rearrange that. Our long side 6 squared minus 2 squared. 36 minus 4. Okay. This was in a calculator paper, so 5.68. So length BC. £5.68 centimeters. Length DC is double that. DC is BC times 2. Okay. 5.68 times 2, which is 10, 11.36. $11.36 centimeters.
Daniel, I think my calculator's not working right. When I did the I get 5.66 instead of 5.68. I don't know why. I'm just hitting square root 32. And it says 5.656854.
I can't read more right.
I'm the same actually now that I've typed that in.
Yeah, 5.66. So 5.32. 11.32. Yeah, I can't read more right. Good show. Okay, have a wee bash at that and we'll see you at 20 past. Everyone get an answer? Anyone
I
want
got
to-
an answer, but I think I'm like way out.
Go for it. What'd you get?
351.
Wow, that's impressive. Anyone raise 351?
I got 19.94.
Well,
That sounds right.
that was a wee bit better now.
Yeah.
Okay, so couple of things, radius 12 centimeters, so from O to A. We can draw that in as 12, and then we can draw a line through the chord, which cuts it in half. We know A to B is 18 centimeters, so half of that means A to where we've cut it, let's call that C, is 9. Okay, now we've got a missing side, OC. Okay. So using Pythagoras, so short side squared equals long side squared minus short side squared. Short side that we're looking for is called OC. And just label it like that if we wanted. Long side is 12 squared, short side is 9 squared that we're aware of. So OC squared equals 144 minus 81. Okay, 63. We'll see. Root of that. Root answer. Okay, so O to C is 7.94. What we need to do is add on or add into that O to the outside. Okay, and we know O to the outside is a radius, so that's 12. So the full distance from that outside edge to C, which will give us the width. 12 radius plus 7.94, which is what we found out. And as Richard said, it is 19.94 and centimeters.
Lol.
Where did you go wrong?
Honestly got no idea.
Does that make sense though?
See, I was like, I had like 24 in my head because the radius was 12 and all of that.
Okay.
So when it was like thinking about the width, I was thinking, oh, it's going to be double the 12 because 12 is only like sort of the halfway point.
So you double the 12 and you've got 390.
I think, yeah, yeah, something along those lines. Yeah.